Hello YouTube, welcome to another installment of Evione Electronics tutorials and blogs. Today we're going to do a review of the Fluke 177 True RMS multimeter. This is one of my own meters, also one of my favorite meters on the bench, not my primary but one of. The Fluke 177 is primarily aimed at electrical work as well as electronics work. Fluke call it their entry into electronics multimeters. I say it is missing a few little features for it to be a true electronics multimeter. Some of those features being duty cycle and true frequency measurements, and quite importantly is microamps as well, which is not featured on this specific meter. Unlike my Bremen TBMs 829, 857, and of course my Fluke 897, which also feature these things. But the Fluke 177 is still a really good meter. If we have a look at the form factor of this meter, it's the standard sort of Fluke meter, yellow build, quite well made overall, nice bail, etc., tilting bail, meter probe holders, etc. The meter is very well designed, very well made, practical. It'll get the job done. Let's get in a little bit closer now and have a look at the meter's features and stuff like that. If you have a look at this meter starting on the left, you have volts AC. Then you have also frequency with your volts AC, which is obviously your frequency of your AC signal. There is also volts DC with a frequency, which I would assume would be more for your sort of frequency of basic pulse width modulation and that sort of thing. Then we have your millivolts DC. This meter does not feature AC millivolts. As an electronics meter, I think they did away with the AC millivolts as it's not really needed for electronics use. It would have been handy though. But DC millivolts. Then you have your ohms, your resistance, and of course capacitance, which is quite new for this sort of series meter. Then you have your continuity and diode test, standard features on most multimeters. Then of course you have your milliamps and your amps. Now if you have a look at this milliamps, it defaults to AC and DC is a second function using the yellow button. This is quite, but it tends to make me believe the meter could have also been designed and leaning slightly towards the AC side of things, being an electrical meter instead of an electronics meter. Right, let's refocus on another section of this meter and let's have a look-see at the ratings, etc. If you have a look here, this meter features 4 input jacks. You've got your standard volts, ohms, diode test, positive input jack, your common, which is your negative input jack. Then you have your 10 amps, your high current input jack, and a 400 milliamp, which is your low current input jack, or your milliamp input jack. This meter is rated to 600 volts Cat 4, unlike the Bremen, which is rated to 1000 volts Cat 4, but 600 volts Cat 4 nonetheless, quite efficient for an electronics multimeter. It is also rated to 1000 volts Cat 3, which isn't as well protected. Let's power up this meter and do a few measurements and see what we find. Okay guys, just before we go into the measurements, I just thought I'd show you. This meter came with quite a nice set of Fluke leads. They are the silicone type. Very nice quality. These have got a nice sort of retractable cover. So when you're working inside a device and you don't want to short out things on the side, you can close it down. And when you want to open them, you just twist and click. And you have your standard full probe. Now these came bundled with this meter. I'm not sure if they come with all the Fluke meters. They did not come with my Fluke 289 and the likes. But anyway, let's get back onto the measurement side of things, guys. Right, now we've got the Fluke 177 set up. I'm going to get it onto DC volts. I'm connecting this specific meter onto a high precision digitally controlled power supply, which I've been working with for a couple of months, which is finally complete. And let's just power her up. Okay, this power supply does give about 20 millivolts output when it's not activated. But let's start at around 1 volt for argument's sake. Power up at 1 volt. Right. I think the meter is slightly more accurate than the actual power supply. But anyway, let's have a look at it. Right, so now we've got our 1 volt input. And we can see we're showing 1,012 volts. on the meter. That's pretty accurate, well within the spec of the meter. I'm going to increase it to 2 volts, 3 volts, 4 volts, 5 volts, and we still have 3 decimal places at 5 volts, which is quite nice, unlike the Unity UT71A, which dropped off down to 2 decimal places at 2 volts. So let's go up 6 volts, 7 volts. So yeah, at 7 volts we dropped to 2 decimal places. I actually think it'll be at 6 points. So let's go down to the decimals. 5.1, 5.2, 5.3, 5.4, 5.5. We're still 3 decimal places. 5.6, 5.7, 5.8, 5.9, 6 volts. At 6 volts, we still show 3 decimal places. So let's go. 6.1, still 3 decimal places. 6.2, still 3 decimal places. 6.3, 6.4, 6.5, 6.6. Let's just go back to 6.5, 6.4. Doesn't really jump back too quickly. So basically it is a 6,000 count meter, but it's got a little bit of leeway. So let's get it up to, let's go to, let's say 12 volts. We're showing 12.01 volts, quite nice. This specific power supply will only do up to 14 volts. Nice and accurate. I could hook it up to my bigger bench power supply, but I feel it a little bit unnecessary. Because, well, we can see the meter is accurate. We know Fluke, trusted accuracy, everything works very well. Also the backlight does appear to be a bit better when I'm looking at it now in this review than it did when I compared it against the Brayman. It will be nice and visible in the dark. We could adjust exposure for this, but hey, I can see what's going on there. I'm quite happy with that. It's not as bright as I would like it to be, but at the same token, if you're working in the pitch black, you don't really want it to be too bright. Right, so let's power down the power supply. Let's get this little guy onto something I'm pretty keen to have a look at is the capacitance feature. How this guy stacks up with measuring capacitance. So firstly, low ohms. Let's have a look at this one. We're going to switch to resistance. And then we're going to couple our resistor across here. And let's see. This is a 0.1 ohm. It is a 5%, so I don't expect it to be 100% accurate. But unlike some of the other meters I've had which don't measure down to 0.1 ohms and 0.2 ohms and the like, this is actually doing pretty well. I'm not going to go through and test a whole bunch of resistors. I think it's unnecessary. 0.1 ohm shows that the low ohm readings works quite well. So we're going to go over to capacitors. Let me just grab a capacitor from my drawers over here. I think that should do just fine. Right, what we have over here is a 63 volt 10 microfarad electrolytic capacitor. Okay, and let's see what we get out of this guy. Wow, look at that, 9.27 microfarads. 10 microfarads, that's pretty accurate. I'd say let's grab something a little bit bigger and see what we get out of it. How about a 4,700 microfarad capacitor? Let's see how that stacks up on this meter. Might take a little bit longer to get a reading. What it showed there is discharge. There might still have been a bit of charge in that capacitor. I've just discharged it now. 4,284 microfarads. 4,700. That could be the capacitor starting to go bad. It is an older capacitor which I pulled from some electronics. Here I have 1,000 microfarad. Let's see how this is a brand new capacitor. Showing 900 microfarads. So yeah, that's pretty reasonable. These capacitors are Chinese branded, so they're probably not the best in the world. Yeah, I'm quite happy with that from the capacitance test side of things. What else can we have a look at over here? I think I'm going to check out the continuity. Let's have a look at the continuity. Right, on continuity, let's see how fast this bugger is. We've got our 2 probes, and as you can see, continuity, very fast, very efficient, works extremely well. I'm very happy with that. Okay, diode test. Let's just quickly pop a diode on over there, and let's see. I'm expecting a 0.7 across, if I can find one of these diodes. I think this might be a germanium, but let's just check it quickly. Go the right way around. We've got our negative. We've got our positive. Yeah, this would be a germanium showing a 0.2 volt drop. Silicone will be about 0.5 to 0.7 volts, but that's fine. That was just for testing purposes. And then, of course, we've got our other things like milliamps and amps, etc. Missing the microamp scale. Something else I wanted to have a look at over here. If you just give me a minute, I'm going to hook up a PWM generator, or hook up a signal generator, and it won't take me more than 2 seconds, or maybe a minute. What I'm wanting to see here is the efficacy of the frequency measurement function of this meter on the DC side. DC frequency, and let's start up. Okay, I see it doesn't really work for what I was hoping, as in it is not. Oh wait, there we go. It is picking up the 490 Hz from the Arduino PWM, but there is no duty cycle measurements on this meter, which is a bit of a disappointment. It is picking up the 490 Hz, so yes, it can measure the frequency for basic pulse width modulation, but that doesn't help if you can't see the duty cycle. To me, duty cycle being more important than the actual frequency, but yes, of course, it does have its purposes. It is still useful, so I'm not going to complain there. It's picking up the 50 Hz AC from the South African power. Quite interesting, that always does. Okay, so guys, basically in closing, that is pretty much it for the Fluke 177 basic usage review. The meter, I can recommend it for electronics benches and stuff like that, but I must tell you, it is a little bit pricey for what it does. A lot more can be acquired for this sort of money. When buying an electronics multimeter such as with Brayman, the TBM829 does a whole lot more than the Fluke 177 for the same sort of money as what you're going to spend here. In fact, for what you spend in South Africa on a 177, you can pick up the bigger Brayman models like the 20,000 and the 60,000 count meters. So definitely something to think about. Also for hobbyists, I do recommend the Unity UT61E as a really good multimeter instead of this guy over here. This guy is a whole lot safer. It's got a whole lot better features about it and that sort of thing. But at the same token, if you're not manufacturing or doing testing on high voltage or any of those sort of things where you actually need the safety and the stability and the reliability of these meters over here, definitely a whole lot more can be had. Talking like that, the Fluke has been a brand I've been using for more than 25 years. They've always been the meter that we go to in the electronics and industry, communications industry, cellular communications industry. Obviously we use the bigger models in this, but they're fantastic. Just general all-around great meters, guys. Thanks for watching, and I hope to see you guys for the next review. Have a great week.